All right, let's break down one of the most critical signals you'll find in any engine room. We're talking about that 4 to 20 milliamp signal from your oil content monitor. Now, I know it sounds super technical, but trust me, getting this wrong can have some really serious consequences. So let's dive right in.
And you know what? That's not an exaggeration. We're asking this because a single, simple number from your bilge water system, if you misread it or misunderstand it, could literally lead to an environmental mess and a legal nightmare. It's a tiny little signal with absolutely massive implications.
The stakes here are incredibly high. Seriously, we're talking about massive fines that can cripple a company, port state control detentions, and even criminal charges against you and your fellow crew members. This is not just about good practice. It's international law that every single engineer has to know inside and out.
Okay, so let's start with the big one, the fundamental rule that governs all of this. It's the one number that draws the line between a legal discharge and illegal pollution: 15 parts per million.
This all comes straight from MARPOL Annex I. 15 parts per million, or ppm, is the absolute, non-negotiable max for oil content in water that goes overboard. To put that in perspective, imagine 1,000,000 drops of water. Only 15 of those drops are allowed to be oil. It is a razor-thin, strict legal limit.
And this rule isn't just based on the honor system. No way. Ships have to have automated safety systems built in. So if that oil content even sniffs the 15 ppm limit, alarms have to go off, and a three-way valve has to automatically, instantly divert that flow away from the sea and send it right back to the bilge tank. It's a critical built-in failsafe.
So how in the world does the ship actually know how much oil is in the water from one second to the next? Well, it all starts by measuring something pretty simple: the water's haziness.
Haziness is pretty much exactly what it sounds like, right? It's just the cloudiness, the murkiness of that bilge water. And that cloudiness is caused by all the junk mixed in there. Oil, little bits of fuel, lubricants, dirt, you name it. And the logic is really straightforward. The more oil and gunk in the water, the hazier it gets.
And this is where that key piece of gear, the Oil Content Monitor, or OCM, does its magic. First, its little optical sensors shine a light through a sample of the water and measure how that light scatters. That tells it exactly how hazy the water is. Then, its brain converts that haziness reading into a precise parts per million number. And finally, it broadcasts that value as our all-important 4 to 20 milliamp electrical signal.
So now we've got this electrical signal, let's really look at how it becomes a perfect real-time picture of the pollution level. Honestly, you can think of this as the language the machine is using to talk to you, the engineer. The whole system is built on this beautifully simple scale. Look at this. 4 milliamps is the best case scenario. It means perfectly clean water, 0 ppm of oil. Then, at the other end of the scale, 20 milliamps is the red line. It corresponds exactly to that legal limit of 15 ppm. Clean is 4, alarm is 20. Simple as that.
And what's so cool about this, and what this chart shows so well, is that it's a perfect straight line. It's a linear relationship. I mean, look at the numbers. At 0 ppm, you've got 4 milliamps. At half the legal limit, 7.5 ppm, you are exactly at the halfway signal point, 12 milliamps. And at the full 15 ppm, you guessed it, you hit the max signal of 20 milliamps. It's perfectly, beautifully predictable.
This just illustrates it perfectly. You can literally think of this signal as a live pollution gauge. If you're down in that low range, say 5 or 6 milliamps, you're green for go. It's a safe discharge. But as that needle starts climbing up towards 12 milliamps and beyond, you're entering the caution zone. And boom, the second it hits 20, the alarm blares and the whole operation shuts down.
All right, so let's tie all this theory together and walk through a super practical, real-world situation that you could easily face down in the engine room. This is where it all clicks.
Okay, so you fire up the Oily Water Separator. You take a look at the monitor, and it's showing a nice, steady 10 milliamps. In your head, you can do the quick math. That's about 6 ppm, well below the limit. The separator's doing its job, the discharge is safe, everything's looking good.
But then, just a few minutes later, you notice something. The reading is starting to climb, and it's climbing fast. Suddenly, it jumps to 17 milliamps. Whoa, that is your warning sign. You are now getting dangerously close to that 15 ppm limit, and you need to figure out why, and you need to do it right now.
Seeing a jump to 17 milliamps is a very clear message from your equipment. It's screaming at you that the oil concentration is going up, which means your separator isn't working as well as it should be. Could it be a simple fix, like a dirty filter? Maybe. Or it could be something trickier, like a clogged coalescer or emulsified oil that's tough to separate. Whatever it is, that signal means stop what you're doing and start troubleshooting immediately.
The system is also smart enough to give you clues when the equipment itself fails. For instance, if you see a reading of 0 milliamps, your first thought shouldn't be, wow, this water is super clean. It should be, uh-oh, I've got a broken wire or a power failure. On the flip side, if the reading goes way off the charts to something like 22 milliamps, that's the system telling you it's over range, probably because the sensor itself is all gunked up, not just because the water is dirty.
So you see, the really crucial thing to get here is that this 4 to 20 milliamp signal, it's not just a passive number on a screen. It is an active, live statement about your ship's compliance, your equipment's health, and frankly, your own professional responsibility.
Have you ever wondered why this specific 4 to 20 milliamp signal is the gold standard for so much industrial gear? Well, it's because it's tough as nails. In a noisy engine room, it's way less likely to get messed up by electrical interference. But the really brilliant part is what's called the live zero. Because the signal for perfectly clean is 4 milliamps, not 0. If you ever see a 0 reading, you know instantly that something's wrong. A wire's broken, the sensor's dead. It has fault detection baked right into its DNA. It's just genius.
And really, that brings us to the most important point of all. Understanding this whole system, from the haziness of the water in that pipe all the way to the milliamp reading on your control panel, it's a fundamental part of your duty as a marine engineer. It is literally how you protect the environment and keep your vessel operating legally and ethically.
So, the next time you're standing watch over a bilge water discharge, just remember that every single number on that display is telling a story. It's a story about how well your equipment is performing, about your attention to detail, and at the end of the day, your commitment to keeping our oceans clean. So what story will your next reading tell?